In today's world, formal education is considered a prerequisite for tapping into one's potential and developing young people into financially stable and successful individuals. The importance of formal education cannot be overstated, as education has been linked to every single positive outcome, ranging from employment to health. However, many students around the world are unable to partake and excel in education, as there likely exists a gender disparity in education, as in over 30 countries, fewer than 90 females for every 100 males completed lower secondary school. Hi, our team consists of Jatin Mehta,
Philip DaCosta,
and Keval Patel.
And we'll be presenting our work on the role of government expenditure in equitable education. This study aims to build upon the work done by Hanushek and Goldman and other similar studies, primarily Gonzalez de San Roman, in examining the correlation between government expenditure and educational outcomes by taking a more holistic approach in our study. Previous studies like theirs indicated that expenditure had little to no impact on educational outcomes after reaching a minimum threshold. Hence, our study aims to examine the following research question from a global perspective. How does government expenditure affect educational participation and outcomes between males and females? The raw data came from a variety of sources compiled using the World Data Bank, which combined gave us 364 variables to analyze. The variables used can be broken down into three primary categories. The first being investment in education. For this category, the particular metric of government funding per student was used, as it is a measure of the amount of money spent on education per student by the public education system. The second one being student participation. And for this category, the out-of-school rates were used, as it's obtained by dividing the total population enrolled in a level of education by the total population for that age range. Thirdly, the student outcomes were the last category, as the harmonized test scores were used for this category, as it is an indicator that holistically measures student achievement across math, science, writing, and reading in secondary education. For this study in particular, the secondary education data was used, as it represents grades between 7 and 12. For data cleaning, three main steps were conducted. The first being data compression, as 20 years of data ranging from annual data from the year 2000 to 2020 were compressed into one mean value for each of the indicators. Then data fluctuation was accounted for, as data points with a relative standard deviation greater than 30% were discarded. Data incompletion was also accounted for, as variables with a count of less than 50 out of the possible 222 countries and territories were also discarded. For data analysis, two steps were conducted. First, the variables of student outcomes and participation were analyzed using distributions and descriptive analysis. Secondly, regression analysis and correlations were conducted between these two variables and government funding.
The following visual recaps our methodology process in three steps, beginning with the raw data, then moving on to the data processing, and then finally the data analysis.
Using the methodology previously indicated by Jen, we first created a geographic overview of government expenditure per student. We found that European countries, particularly those concentrated in Northern Europe, have the highest educational expenditure per student. However, educational spending is not limited to Europe alone, as countries like the United States and Australia also spend high amounts on education. Using this information, we then compared GDP, gross domestic product per capita of a country, to their educational spending per student. What we found is that there is a strong correlation between the two variables, suggesting that GDP heavily affects the government expenditure of a country. From this, we observed that countries towards the bottom right side of the graph tend to neglect educational spending, such as Australia, while countries on the other side of the trend line, top left, prioritize educational spending as a percentage of their GDP. Additionally, there tends to be a cluster of countries that spend less than 10K on education. From our results on GDP and government funding, we then transitioned into examining student participation and how government funding affects student participation. The graph presented illustrates the distribution of male and female's out-of-school rates against an exponential curve. For both male and female scores, the results are statistically significant with very high R-squared values. In terms of the differences between both sexes, it can be seen that the out-of-school rate for females is higher in the tails. Using this information, our team examined student participation and found that there is a higher variance in the out-of-school rates for females, with European countries tending to be outliers such as Luxembourg and Denmark. And when examining this difference, our team determined that the female out-of-school rates tend to be much higher, and that this difference is extremely high when the government provides less than 2K in funding.
The final variable that was analyzed was harmonized test scores. The following histogram illustrates the distribution of harmonized test score averages for each country in the data set. The harmonized test was originally designed to be normally distributed for any sufficient diverse group of students. However, when comparing different countries, the data appears bimodal. In addition, a Shapiro-Wilk test revealed that the distribution across different countries did not behave as a normal variant, as the W values for men and women was less than the critical value. The following QQ plots help illustrate how harmonized test scores for males and females deviate from this expectation. In the graphs, the red line represents the expected values for a normal distribution, and the black dots represent the actual test scores for each country. Importantly, this deviation implies that there are factors within each country that may influence a student's educational outcome. One potential factor is government expenditure, as it can be seen from the scatter plot presented that government expenditure for both males and females has a statistically significant effect on harmonized test scores. Specifically, between the two variables, there was a strong logarithmic correlation for females and males. Finally, we can compare the differences in harmonized test scores between males and females to investigate potential gender biases. The difference in scores is calculated by subtracting female scores from male scores. From this, both datasets are correlated against government expenditure, and as one can see, there is a significant correlation with a p-value of less than 0.001 for countries which have male scores greater than female scores, but not vice versa. First, we can see that GDP has a significant effect on government expenditure, which suggests that certain students may not receive the aid they require to optimize their educational experience. However, further investigation is required to determine what other factors may influence government expenditure, such as Hofstede cultural dimensions, a set of quantitative variables that allows one to assess cultural and social norms. In addition, it can be seen that out-of-school rates for both males and females exponentially decrease as government expenditure increases. In terms of application, the strong correlation could be used to dictate distribution of resources for a particular international charity, or one that operates within different countries around the world. From the Shapiro-Wilk test and QQ plot, it can be seen that the test scores observed deviate from expectations of normalized test scores. These differences indicate that each country has individual factors which impact the score for both males and females, with one potential candidate being government expenditure. This provides support that monetary factors significantly affect a country's education, leading some students to be at a disadvantage. Furthermore, a similar trend arises when analyzing the differences between the sexes. We can see that the differences between male and female scores are significantly correlated with government expenditure when the male scores are greater. This particular result can inform countries to how much money they should allocate towards education or other social necessities to eliminate gender biases.
We believe some of the strengths of our study mainly include having a large sample size, a significant time period, as well as using recent data and public education data with a variety of variables. However, some of the weaknesses in our study were mainly due to the limited economic factors we analyzed, mainly being that we only analyzed the GDP, social norms were unaccounted for, and perhaps annual fluctuations were not handled precisely.
Just to recap the main points of this investigation, we have three major takeaways from our study. Firstly, richer countries tend to spend more on education. This means that as a country's GDP increases, they tend to invest more in programs and resources supporting student education. Secondly, there's an inequality in student participation and outcomes between males and females. However, investments in education up to a threshold of $15,000 decrease this difference, creating a more equitable education. That being said, educational outcomes, specifically female harmonized test scores, tend to be higher regardless of government expenditure. Thus, increased government expenditure has shown to decrease the gender gap in education. Although it's important to recognize that government expenditure may be one of many factors affecting educational participation and outcomes for both genders. Hence, while government expenditure is shown to make education more equitable, a broader study must be done to determine a more definitive solution for improving equity in education. And so to expand upon this investigation, a study using cross-correlation analysis between the out-of-school rates and harmonized test scores, as well as government expenditure can be conducted to determine if there are any significant temporal trends. Or we could potentially examine the role of social norms in influencing educational outcomes and participation. For example, looking at Gert Hofstede's cultural dimensions. Nevertheless, governments, particularly those in developing countries, should prioritize investment in education up to $15,000 in an attempt to achieve more equitable education. Then expenditure should be prioritized towards healthcare and other social aspects.